Our next subject is practical antennas. Here you see a number of practical antennas, including a dipole, some verticals, and some Yagi antennas as well. As horizontally polarized antennas such as dipoles and Yagis are raised, ground losses drop to a negligible level. As such, an antenna is raised, the vertical angle of maximum radiation drops until a height of 1/2 wavelength is reached. Raising the antenna further causes additional lobes to appear in the elevation pattern. The terrain on which an antenna is mounted affects both the azimuth and elevation pattern of an antenna. A hilltop is highly sought after because it is likely to reinforce the signal at low takeoff angles. The takeoff angle is important because of the critical angle. The critical angle is such that if it is too high, the signal will be lost into space. If you are below the critical angle, the signal will be reflected by the ionization layer. Near vertical incident skywave antennas, NVIS, are most efficient when mounted near the ground, for instance at least 1/8 of a wavelength above the ground. NVIS systems can be very effective for communicating in very hilly terrain. This drawing shows a typical bumper-mounted HF mobile antenna. Guy lines can be used to help stabilize the antenna. A tri-band antenna for 20, 15, and 10 meters can be constructed using traps. On the resonant band for each trap, it acts like an open circuit, isolating the outer portions of the antenna. Below resonance, the trap is inductive, acting as a loading coil. A folded dipole antenna is a wire antenna made from one wavelength long wire that is formed into a very thin loop, 1/2 wavelength long. The folded dipole has the same directional characteristics as a regular dipole, but its feed point impedance is 4 times that of a regular dipole, and its SWR bandwidth is wider than for a single conductor antenna. How does the radiation pattern of a horizontally polarized 3-element beam antenna vary with height above ground? Answer A. The main lobe takeoff angle increases with increasing height. B. The main lobe takeoff angle decreases with increasing height. C. The horizontal beam width increases with height. D. The horizontal beam width decreases with height. The answer is B. The main lobe takeoff angle decreases with increasing height. What happens to the feed point impedance at the base of a fixed-length HF mobile antenna as the frequency of operation is lowered? A. The radiation resistance decreases and the capacitive reactance decreases. B. The radiation resistance decreases and the capacitive reactance increases. C. The radiation resistance increases and the capacitive reactance decreases. Or D. The radiation resistance increases and the capacitive reactance also increases. The answer is B. The radiation resistance decreases and the capacitive reactance increases. What is the approximate feed point impedance at the center of a 2-wire folded dipole antenna? A. 300 ohms. B. 72 ohms. C. 50 ohms. Or D. 450 ohms. The answer is A, 300 ohms. Rhombic antennas are usually characterized as high-gain antennas. They have a wide frequency range and a bidirectional pattern that doesn't change much over their entire frequency range. The radiation pattern is bidirectional. If the antenna is terminated, the pattern becomes unidirectional. And now for Beverage antennas. The Beverage antenna is a receive-only antenna. This antenna acts like a long transmission line with one lossy conductor, the earth, and one good conductor, the wire. Beverage antennas are effective directional antennas for 160 and 80 meters. Notice that it is long and close to the ground. Using two verticals fed with various phase relationships has become very popular with de-expeditions. This is because there is less equipment to haul and because various pattern shapes can be obtained. Here are just two examples of two antenna patterns. You can see how beneficial this capability would be to a DXer. Here are more examples of two vertical patterns. When you are assessing total system performance, accounting for the effects of the entire system is important, including antenna gain. Assume a 150 watt transmitter, 2 dB loss from the feed line, 0.2 dB loss from the antenna switch. The antenna, assume, has a gain of 7 dBd. What is the effective radiated power? Well, system's gain equals minus 2 dB minus 0.2 dB plus 7 dBd, which equals 4.8 dB. Effective radiated power is 150 watts times the inverse log of system gain divided by 10, which equals 150 times the anti-log of 4.8 dB divided by 10, which gives you 453 watts. Our next topic is satellite antennas. A number of satellites use 2 meters and 440 megahertz. One band is used for the downlink frequency from the satellite and the other band for the uplink. For this reason, you need two antennas, such as the example that you see here. Two Yagi antennas built on a single boom with perpendicular elements creates a circularly polarized antenna. The driven elements are fed 90 degrees out of phase. Here is an example of a small loop antenna. For instance, in a single turn loop, the conductor should be less than 0.8 wavelengths long. Loops used for receiving are used for their nulls rather than for their small gain. Figure A shows the pattern for an ideal small loop. Figures B, C, and D show more realistic patterns for a small loop. Several turns improves the sensitivity of the small loop, although the total conductor length must still be less than 0.8 wavelengths. Our next subject is direction finding. Radio direction finding is as old as radio itself. The equipment for radio direction finding has improved over the years.